This video's topic is going to be on the chain rule. And for the chain rule, this is going to look a little complicated at first as we go through this, but just bear with me and I'll try to simplify it as we go along. Here we're looking at, it says that if y equals f of u is a differentiable function of u and u is equal to g of x. So what we're saying here is u is equal to some other function g, and if that's a differentiable function of x, then that means y is equal to f of g of x. So if you notice here, all we're doing is saying that u down here is equal to the function g of x. And what that gives us then here is y equals f of g of x. We have a composite function where g is the inside function of f. So that means if we have y equals f of g of x, which is a composite function, if this is a differentiable function of x, then the following is true. If we want to find the derivative of y with respect to x, it's going to be equal to the derivative of y with respect to u, dy du, multiplied by du dx. Okay, now we're going to go through this form here, and then a little bit I'll come back and explain this second part where we have the derivative of f of g of x. So once again, just bear with me as we go through this explanation of dy dx equals dy du multiplied by du dx. And if you notice here, if we multiply, essentially what's happening, if you think of this as multiplication, the du's would cancel out and you're left with dy over dx. So I want to go through this explanation using the following function here. Y equals 2x to the fourth plus 1, and the whole quantity is cubed. So if you notice here, we have an inside function and an outside function. So up here we said u, the g of x here, u is representing the inside function. So if I let u equal the inside function here, that would be the 2x to the fourth plus 1. Okay. So essentially then over here we would have y equals u cubed. Okay. So if you notice, one of the first things we want to calculate is we need to, first of all, we need to find dy du, and we need to find du dx. So here we have substituted in the place of 2x to the fourth plus 1. We said we're going to let that equal u. So that means we would plug u in for the 2x to the fourth plus 1, so we have u cubed. So if we want to find this dy du, that means we need to take the derivative here, dy du. Well, that is simply u cubed. Well, if we can easily take the derivative, that would just be the power rule, 3u squared. And then over here, we need to multiply that by the derivative. We want to calculate du dx. So we take the derivative of u with respect to x. And if you notice here, u is in terms of x, so we simply take the derivative using the power rule again. So we would have 8x cubed. So if we're trying to find dy dx, we're going to take dy dx is going to be equal to the dy du multiplied by du dx. So if we do the substitution, then we're going to find that dy dx. And again, notice here, essentially what's happening is the du's here are going to cancel out, and we would have our dy dx. So dy du is 3u squared, and du dx is our 8x cubed. Now, what's wrong with this example, or this form? Well, if you notice here, this answer has x cubed and u squared. Well, we want the answer to be strictly in the terms of the variable x. So that means we need to resubstitute to get rid of the u. Well, if we go back up here, we said u was equal to 2x to the fourth plus 1. So down here, we can resubstitute and we can write 3 times u. Well, u is 2x to the fourth plus 1. And this is multiplied by the 8x cubed. Now again, I know this seems really involved, but just bear with me. We're going to make this a little bit easier. So all we did was take this part here, u equals 2x to the fourth plus 1, and we wanted to substitute this into u so that we get 2x to the fourth plus 1. So now that we can see that the answer is strictly in the terms of the variable x. So from here we can simplify the expression, and we can do that by simply multiplying. We could distribute 3, but before we do that, I'm going to actually take the 3 here, and I want to multiply 3 times 8, and we would end up with 24x cubed multiplied by 2x to the fourth plus 1. And at this point, if you wanted, you could distribute this, but I think in this situation, I'm going to go ahead and leave this in factored form. So there's our derivative dy dx. Now, once again, what made this so different from examples we looked at before is up here, we have 2x to the fourth plus 1 cubed. We have this cubed part. Before, the only way we could have solved this using our derivative techniques would be to actually cube this binomial. We'd have to multiply this out 3 times, which could be rather time consuming, especially when the exponent here gets to be very large. So the idea is we have a composite function. The inside function is the 2x to the fourth plus 1, and the outside function is the cubed part. So now I want to go back and look at this example one more time. We're still going to look at y equals the 2x to the fourth plus 1 cubed. But I want to now try to explain this in a little bit more simpler fashion. Looking at this part here, the derivative of f of g of x. Well, the g of x, this is the inside of our composite function. Okay, so the first step here says that we want to take, first of all, the inside function is the g of x, and the outside function is our function f. Okay, so if we look at the formula, it says f prime of g of x. Basically what this is indicating here is that we want to take the derivative of the outside function. Okay, and if you notice, we're going to leave the inside function alone. So the first step is just simply take the derivative of the outside function, and then we're going to multiply that by the derivative of the inside function. G prime of x says we're going to take the derivative of the inside. So I'm going to show you this is going to be a whole lot easier. So once again here, what we're going to do is if we want to find the derivative y prime, then we're simply going to take the derivative of the outside, and then you're going to multiply that by the derivative of the inside. So let's try that. Well, the derivative of the outside is the x cubed, or the cube part. So basically, you're going to treat the inside like one giant variable. And that's why over here we use the letter u to represent that. So here, just treat this part, 2x to the fourth plus 1, as if you had x cubed. So if you had x cubed, then we know the derivative would simply be 3x squared. So for us, we're going to do the same thing here. We're going to pull the 3 out front. So this would be 3 times 2x to the fourth plus 1. Again, all of this stays the same. Decrease the exponent by 1, so that becomes a 2. So there's the derivative of the outside function. Next, we need to multiply this by the derivative of the inside function. Well, the inside function is simply the 2x to the fourth plus 1, which would be 8x cubed. And once again, if we take and we multiply the 3 and the 8, we get 24x cubed multiplied by 2x to the fourth plus 1 quantity squared. And if we compare this answer, this is the same thing that we got over here. So I told you it'd be a whole lot easier using this technique. Now you're thinking, why did I go through this whole process on the left? Well, I wanted you to understand the idea of the inside function being u and how we would go through the process here, what this means when we're finding dy du and du dx. But really from here on out, you don't need to go through this whole process on the left-hand side. That was just a way to break it down to show you a little bit more behind the formula so that you can understand this. So once again, the easiest way to think of this as you have your composite function f of g of x. We're going to take the derivative of the outside function, and the inside function then remains the same. Then you're going to multiply that derivative by the derivative of the inside function. So here again, 2x to the fourth plus 1 is the inside, the cube part is the outside.